Our next speaker is Alex Pogmore. So he is a PhD researcher in digital twins and immersive environments for the built environment. So Alex's experience is in the immersive virtual environments, engineering psychology, BIM and digital twins. So it sounds like it's going to be a really exciting conversation. So the session is focusing on if teams can complete engineering tasks remotely in a digital twin-enabled cave as effectively as if they were really on site, and understanding social and technological barriers to remote work in collaborative VR. So,
thank you very much.
There you go.
A mouthful, I know.
Yeah.
Okay.
Oh, and just in case there's anybody else in the room, you didn't get this earlier, if you would like to scan the QR code so we can get those responses, that'd be fantastic. And again, there's the QR code, so you can ask your questions via the Slido.
Sorry.
Okay. There you go. I'll leave you to it.
Great, thank you very much.
So with that further ado.
Yes, thank you very much. And thank you for an amazing presentation. Very hard to follow that, but from someone who's obviously at the top of their field to then someone beginning their research journey, the PhD. My name is Alex. I'm from Fulcro and the University of Birmingham. It's my PhD essentially on using the Fullmax cave created by Fulcro and understanding how decision-making in teams changes from on-site, so how teams usually work in construction, to then being in a cave augmented with life sensor data and BIM and digital twins. So without further ado, me. So PhD research at the University of Birmingham. As I already said, immersive environments, digital twins, and human factors are sort of my three main areas of focus. And my background is a master's in civil engineering, and that's kind of where my journey sort of started. So when I was doing my master's project, my final year, I was looking to do a dissertation that was not from the sheet, not from the book, right? So I went on LinkedIn and I managed to find Ian Misgiven, and he directed me to Max, directed me to the University of Birmingham having 2 full Max caves, and from all the way from my master's into a PhD, it's been about a 3 or 4 year journey now with Fulcro. So just an outline. Kind of covering the context of the situation before jumping into what PhD does. So looking at challenges and opportunities within the construction sector and AEC generally, and then sort of a certain focus onto what I'm applying my research towards, and then how the cave fits into wider extended reality, and more on that later. And then my PhD itself, so the research question, how I'm tackling that question, both through literature and then through the system that I've made, and how everything sort of fits together to make one final solution. So without being too morbid, health and safety in construction is not brilliant. And it's one of those things that I'm sure we'll hear more about today and tomorrow with other tracks, but as you can kind of see some of the deltas and the changes in the past 9 years, other industries and manufacturing, which is sort of, I think, a sister sort of industry to construction, have sort of converged and decreased generally in the past decade, where construction sits still pretty high. And I think the thing that I really think is most interesting is the fact that it's increased by 0.5 deaths per 100,000 people in the past 9 years. And it's gone up and down, but it's not something that we can sit back and accept, and I think it's on all of us to make changes. So, highest number of fatalities, and there's many reasons why this is. There's a high number of complex tasks happening on site at the same time, coordinating activities, and the culture and embracing, staying to the standards and governance in place. That's also driven by the need to be efficient and to work efficiently on construction projects to drive profit. And so health and safety is one factor that's challenging, but then net zero affecting all of our sectors really, and the drive to be a net zero by 2050. Just generally, the built environment accounts for 40% of the UK's CO2 emissions. We have to bear some responsibility within ourselves to ensure the entire life cycle is reduced carbon footprint. And then profitability, traditionally, kind of 3% is not brilliant. And talking about project costs and how they dictate how much we tender and bid for, we can really identify cost as being something that we should target to reduce. So at the same time, there's opportunities. And there's some key terms up here that have become sort of like buzzwords, but the fourth industrial revolution essentially comes after steam, after electricity and IT. And it's sort of the past 10 years, but we're seeing essentially the creation of cyber-physical systems. So things like digital twins for improving our operations. And that includes automation and AI. But the main thing that I like to talk about with digital twins is this diagram. And this really helps to ground my understanding. So at the top, we have digital models, and that's things like BIM models, where you have a reflection of the real in the virtual, okay? But that's kind of static, that's fixed at one point in time, for example, as built drawings. And then we have digital shadows, which have a live data feed to reflect the real conditions. But then digital twin actually acts on those conditions, simulates on those conditions, and suggests actions to the real world with or without a human in between. And digital twins do have less uptake than, say, BIM, as we can see here. But I do believe that BIM and digital twins, as we are taking live sensor data from BIM model and BIM model static data and making digital twins, they are part of the same sort of stream. So, as I mentioned, BIM we also have, which is the information process and procedure that we go through, making sure that all our project information is gathered in one place and everyone's working on the same page. We also have extended reality, and that's kind of a blanket term for AR, MR, and VR. Which I'll go on to in a minute, but each essentially offers their own unique benefits and challenges, but we haven't really experienced or explored how these three can be integrated together. So what is the Fullmax cave? So you can kind of think of it as an open shoebox, one long side's open and the rest is projectors with a central left-hand screen. So you have over 180 degrees of viewing of 4K images. You can fit about 20 people inside, and it creates this really immersive, high-fidelity, multi-user environment. And my research is based upon this. And a question I always get asked is, why would you use a cave when they are more expensive than individual headsets and not just use head-mounted devices like VR devices? And my question to you is, have you ever seen more than one person in the same space use a VR headset? Because it's quite funny. Because everyone is in their own little box, little area, being turned around, facing the wall, talking to the wall. You lose the gold standard of communication, which is me looking at you and being like, do you actually care what I'm talking about right now? And I can see that nodding means yes. But compared to a team call, for example, cameras are off, or maybe you're a cat by accident, you lose a sense of understanding between humans. And so in this environment, it's really amazing to convey BIM challenges and problems. For example, if you're on a Teams call and you have an engineering problem to solve together, how many minutes does it take you to figure out what you're actually talking about, what the issue is you're facing, versus in a cave environment where one person directs you with an Xbox controller, and you can see not only the problem in a 3D environment, but also the wider context of what that problem influences and how design can change. So there's many applications, and Fulcro offers this alongside their digital advisory services for project management. But some of them just there, design review, clash detection, risk management. And at the University of Birmingham, I use it for teaching MSc students about risk management. So viewing a BIM model of a university station and seeing, can you identify places in which risks will occur? So how does that fit into XR? So as I said, XR is extended reality. It kind of takes everything on a spectrum from reality to virtuality. And you are increasing the amount of the virtual world while decreasing the amount of the real world you're seeing with these products. So AR are things like Snapchat filters, as we heard earlier, but things which overlay with reality. MR, mixed reality, is kind of the hardest to pin down, but that's the mixed. So it's the virtual interacting with the real world. So things like engineers being guided on site by seeing what they should be doing with the tools in their hands, for example. And then virtual replaces reality at the VR level, so MetaQuest and Vive and the headsets where you can't even see your own body. And I put a plus there just to talk about, this work? No, just to talk about synthetic stimuli, so wind or smell or the sense of being in a completely different place because other stimuli are applied upon you. But the creators of the cave in 1992 saw that with virtual reality, we must incorporate a sense of multi-user and keep the important aspects of communication, so having people together talking at the same time. So, my PhD, all that's great, but what does that actually fit into it? I'm investigating if we can take, for example, control room users, remove them from the hazardous on-site location, augment them with things like BIM models and life sensor data and digital twins to see if they can complete their task as effectively as being on-site. So that not only means teams by themselves looking at life sensor data, but also if we could have a team directing one person who's augmented on site, or directing that person and things like a robot. And all this is possible through platforms like Unity. There's many integrations now that we have with engineering platforms, and the gamification we're seeing of our sector. But the real question is both, can we do it, and what changes? So my PhD started very much in the technical aspect of how I'm going to make this work, how do I get the life sensor data into the cave, blah, blah, blah. And really quickly, I realized there's a duality in my PhD, which is the psychology behind it. So as a team, how do you make decisions? What changes? How does your cognitive load change and situational awareness change? So this diagram kind of splits up the factors that influence people performing tasks. So we have both individual factors, so things like your personal mechanisms, your long-term memory stores, your working memory, your objectives, how you've set about to do a task. But you also have the task and system, so how complex the system is, what features it does and doesn't have, the task itself, how tolling is that on your workload. So then cognitive load is essentially what it sounds like, how much is happening in your headspace, how much of that is being directed towards the task you're doing, and how much of that, of your attentional resources are being taken away from the task you're doing by other stimuli. So things like stress and anxiety of being in a situation, which is quite scary, quite presenting. The situational awareness is something that started in the air traffic control space, and it essentially means being aware of elements in a system around you. Okay, so if you imagine someone sitting in an ATC control tower and thinking about planes, but not only the planes, but their velocities, and then in 5 minutes' time, what that actually means is there going to be a collision. So it's kind of a way of measuring the usefulness of a space in my application to see if we can achieve the highest level of situational awareness as if we're already on site, or by using an XR product. So, like any good PhD student, I started with a systematic literature review.
Yes.
Yeah. Which is just below meta-analyses being the top thing you can do to try and survey literature and try and answer a question. So I had quite a broad question, which was quite painful to try and pin down, but essentially I was looking at what the previous applications of caves were in the built environment to understand what it has and hasn't been used for, just to look at the gaps. As you can see, this beautiful Sankey diagram starting with over 2,000 papers all the way down to 107 in the end. And what did I find? Well, I kind of found that there were many applications of caves to research. So creating environments mainly that are difficult to create or are hazardous, such as tunnel evacuation, such as healthcare, or even in rehabilitating people, so showing people who have extreme anxieties to certain, exposing to certain stimuli, or stroke rehabilitation, or autism diagnosis, this kind of thing. But within our sector, I didn't see any replication or any at all of BIM digital twin caves. That is, taking BIM models, applying sensor data into a cave. It's quite a niche thing. I also only found one study of situational awareness, and it wasn't applied to AEC, it was to do with aircraft. And there's no joint study of the top 7, as I have called them. And it's these factors here. So fidelity, so that is the quality of information you get from the tool you're using. Usability, self-explanatory, how well you interact with that, how well it's designed for humans to use. Cognitive load, so that mental workload you have. Stress and anxiety, so external factors. presence, how likely or how well you feel you are in a situation, both socially with somebody else, but also in that space, and situational awareness. And you can see some of the numbers here about the papers, how they sit in between, what they measured. And I found there was no joint measurement and a very small number, one, that measured situational awareness. So I realized that these are important because I identified them before doing my static review, but then it was backed up by the review itself as they were really prevalent, and I found lots of different measurement techniques that I could use to measure them. So next, I wanted to create the actual platform technology to assess both the cognitive and decision-making performance in a cave and reality. So, without going into too much detail, I essentially used an array of Raspberry Pis, which are really tiny computers, with temperature and humidity sensors on them. I then fed them through Node-RED, which is an IoT platform, into a database that was read by Unity, and in Unity we had a BIM model, and then visualized everything within the formats, so the cave environment we have. And you can kind of see it here. It's quite a hard thing to convey. But in the top left, we have the School of Engineering model itself, the BIM model, as built as it was 2 years ago. And then through the light sensor data that I managed to get through IoT, we can see, for example, here by placing objects at the same locations as the sensors and applying a context scheme for what temperature and humidity actually means. So in an office space, researching what the actual regulations are for highest, lowest, optimal temperature, showing that to the user in that environment. So actually you are augmented to the effect of being in the real space. And then give them additional functionality. So saying, if you want to pin a particular sensor data to the lectern PC, or you explore somewhere else to compare values, you can do that. Or you can send control signals back out to the real world. And the point of all of this actually is that while it's great we can do this, and I've covered some of the challenges, opportunities, is this environment good enough to perform tasks as if you're really on site? And by having this control loop back to the real site, I'll be doing experiments. So at the start, it will be one person in real reality doing some sort of situational awareness task, whether that is counting cars going past or watching somebody throw a ball back and forwards, recording that in 360 and playing that back in the cave and doing a set of measurements. So thinking about task performance, presence, cognitive load, situational awareness. But then applying that again to a group of people and seeing that how people change in terms of their interactions, their communication, collaboration in a cave versus reality. People talk more or talk less, or they feel more or less engaged. Is there other stimuli around them, like noise of traffic and cars? And how much information should we give them to optimize performance? And then I want to do some industrial data collection. So I want to find out what tasks we could recreate and would be good industrial settings to then apply the same experiments to. So have somebody do a design review, or have somebody try and find a leak in a building, for example, using BIM data versus actually on site. And again, seeing if we do that with individuals or a group and seeing how any of that changes. And so through this process, I'm hoping to refine what we need from the caves, their actual requirements, understand how the different factors influence each other in terms of is decision-making improved by a sense of presence? Is there a critical point at which too much presence is bad? And then all this is going to feed back into creating a more effective environment, hopefully, and create a place in which people can do work remotely. For example, if people wanted to control multiple sites, you could have users, instead of traveling to those locations and having the CO2 implications, the health and safety implications, the cost, the time taken, the de-skilling, you could have them centrally in one space, co-located with that gold standard of communication between them, making decisions collaboratively from the ground up and influencing multiple sites. And that's essentially my PhD. Thank you.